Aloha and welcome. In this video, we're going to talk about zero trust. Well, in traditional perimeter security, you normally trust your internal network users and devices, and you worry more about the external threats, the threats from outside your network. Well, there's a new, relatively new paradigm here called zero trust. And zero trust is operating on very different assumptions than the traditional perimeter security has. So in the zero trust model, you're going to be continuously authenticating and authorizing and validating the security configuration for all of your users and devices, not just the ones that are external. You no longer care about whether they're inside or outside because you've come to realize that, well, in today's world, we've got a lot of online resources, a lot of cloud-based services, and we're doing a lot of remote work. So you may have users that are inside the system. You may have insider threats. You may have external threats. So the idea is that you trust nobody and you verify often. So in the zero trust network, you're going to be following the following principles. First, you're going to assume that the network is compromised, that there is no trusted area. The second thing is you're going to assume that there's external and internal threats that exist on the network. You're also going to come to the conclusion that the device location, internal or external, is not sufficient for deciding your trust levels. Also, every device user network flow is authenticated and authorized. And policies must be dynamic and derived from several data sources. So, uh, going a little bit further into this, when we talk about the components of a zero trust network, the two main components are the control plane and the data plane. So, in the control plane, we've got the policy engine, the trust engine, the data stores, and the policy administrator. So, that breaks down to you've got the policy engine, which is going to be the component that determines the application of policy for each request. You've got the trust engine. The trust engine is the component that scores the device and end user trust. The data stores, that's the component that stores authentication data for requesting device and users. And then you've got the policy administrator, and that's the component that's going to administer the policy decisions, and they're going to do the establishing or blocking of connections to protected resources. The other part of it is the data plane, and the data plane is responsible for enforcing security policies and controlling data access within the network. So the data plane, that's going to include your device and user, your policy enforcement point, and your protected resources. So device and users, that's going to be the components that are requesting access to protected resources. The policy enforcement point, the PEP, that's going to be the component that enforces the policy decisions. Then you've got the protected resources, and that's the component representing the assets that are secured by policy enforcement. And they have a good illustration of this inside the text. I'll go ahead and pull this up. So when you look in here, you see that, well, let's go ahead and start it. So a user requests access to a protected resource, and that's where the PEP is. The request is intercepted by a policy enforcement point. Just think of that as, the intersection point with the data that you want to access. So once you hit that, the PEP is going to send this request to the policy engine. So you're going from the data plane to the control plane. So in the control plane, the policy engine is going to communicate with the trust engine, which is over here. And then the trust engine, it's going to connect with the trust engine and the data stores. And then it's going to determine whether or not you have it's going to determine whether you should get the access or not. Then it's going to send the results to the policy engine. Then the policy engine is going to send the decision to the policy administrator. And the policy administrator, they're going to establish a secure connection to the protected resource if access is granted. And that's how this system works altogether. We go from end user to the, trying to access the resource. The PEP is going to intercede here. They're going to send off a request to the policy engine, pulling information from the trust engine, the data stores. It's going to come back to the policy engine, go to the policy administrator, and the administrator is going to allow them access the protected resource or block access. So zero trust authorization. So in a zero trust network, you can do fine-grained dynamic policy control access based on resource and user device trust scores. So that trust score is really important. Applying policy against multiple data sources allows for granular authentication decisions, which improves the network's overall security and user experience. So the example they give here is a login from a employee's new laptop prompts additional authentication for accessing a sensitive database while allowing access to the employee's calendar. So remember that all access is going to be granted on a temporary basis. That's going to require that users and devices to go, they're going to have to undergo regular reauthentication. So if you change something about the user or the device, their trust score may, change as a result, and that can lead to, their connection being blocked, or it could require them get additional authentication. So one thing, a really nice phrase is air gap networks. So air gap networks refers to a physical isolation of something. So let's say you take a computer that is highly sensitive and you just remove the access to it. So I'm not talking about like access in terms of, taking the user, emptying out the user database, something like that. I'm talking about physically disconnecting it from the, from the actual network. So we say air gapped. In other words, you put air between that system and the rest of the network, so you can physically isolate them, and you can still have security issues with air gapped equipment. There's been all kinds of interesting hacks, like when there's been hacks where they've looked at the blinking lights on devices to determine things, so it's pretty amazing. But generally air gapped makes something a lot more security uh, ironclad, I guess, than it would be otherwise. But this is going to be called air gapped, and you'll see that, and you'll hear about it in reference to military facilities and critical infrastructure systems. So that's a phrase that I want you to be aware of. So, anyways, to recap, we're talking about zero trust framework here, where we don't care where a user is. We're considering that the whole network could be compromised. Everybody has to be authenticated and authorized in here. And the policies, they've got to be dynamic and derived from several data sources. We've got the control plane, we've got the data plane, we've got the different elements of the control plane, like the policy engine, trust engine, data stores, and policy administrator. The data plane side, we have the device and user, and then we have the policy enforcement point, and we have the actual protector resources themselves. So, and then we have zero trust authorization, just talking about using trust scores and everything. So your trust scores can change depending on your situation. So and then lastly we have the concept of being air gapped. So air gap being they're not physically they're physically isolated, they're not physically connected. So that's it for the lesson. If you have any questions, feel free to ask and I'll be happy to help. Aloha.